Okay, in this video, we're going to be looking at probability density functions. The probability density function f of x of a continuous random variable x is defined for all real values of x, and it has these properties. The first one is that f of x, the function, will be greater than 0 for all x, and that's because you cannot have a negative probability. So there are no negative probabilities. So f of x must be greater than or equal to 0. And the integral of f of x, and remember that the integral means the area under the curve, so the integral of f of x is equal to 1. A whole probability, all the probabilities added up together have to equal 1, and so that's what this is. Now, you already know how to evaluate integrals, and so a lot of this lesson is just going to be me showing you the formulas and showing you how to set this up. I'm not going to evaluate every single integral to save time on the video, so you already know how to do that. So the probability that x lies in the interval a to b, so the probability that x is between a and b, is given by the area under the graph of f of x between a and b. So if we wanted to find the probability that x is between two numbers, a and b, we would just do the integral from a to b of f of x. So now we're just going to look at some examples. The continuous random variable x has the probability density function given below. So you see this here. And so what's going to happen is you have your function here, and then it's going to give you where this function is valid. So this function is valid from -1 to 1 for our x values. Otherwise, it's 0. So we can only use values from -1 to 1 for x. The other issue here is we have a k out front. And so part A is asking us to find k. So we have to use one of those properties we just talked about. We know that the integral from -1 to 1, so the whole area under the curve where this exists, of k times 1 plus x squared dx should equal 1. So the whole area from -1 to 1 should equal 1. And doing this is going to allow us to solve for k. So that's an important rule that you have to remember. And so you can either bring the k out front, like this, and integrate this, or you could have distributed the k and done it that way. If I do this, I'm going to have, when I integrate 1, I get x. The x squared is going to become x cubed over 3. And we want to evaluate this from -1 to 1, and we know that it equals 1. Okay, so I'm going to go through this one to find k, but you have done this. You have evaluated integrals. And so now I'm going to plug in my 1. So this is going to be 1 plus 1/3, and then minus, when I plug in my -1, I'm going to get -1 minus 1/3. And again, all of this equals 1. So this, when I do this, is going to give me 4/3 k minus, this is going to give me -4/3 k equals 1. And so obviously this is 8/3 k equals 1. So when I divide by 8/3, k is equal to 3/8. And so now I could plug that value in here and do other things with this probability density function. Okay, so just knowing the rule that the area from -1 to 1 must equal 1 will allow me to solve for a missing value here. Okay, so we're going to use the same example, but we know now that k is actually 3/8. So this is 3/8 times 1 plus x squared. I could also distribute that and write 3/8 plus 3/8 x squared. Okay, now we're asked to find the probability that x is between 0.3 and 0.6. And as long as these values are between -1 and 1, I can just do the integral from 0.3 to 0.6 of f of x here. So of 3/8 plus 3/8 x squared. And then you can evaluate this. And again, you know how to do this integration, so I'm not going to do that part. But you should, and you should check your answer. And when you do all of this, you get 0.136. And so the probability that x is between 0.3 and 0.6 is 0.136. So a small probability. All right. So again, probability that the absolute value of x is less than 0.2. So you have to know what this means from a long time ago in the class. You have to know that when I have the absolute value of x is less than something, I'm going to take that value and say x is between the negative and the positive. So what I'm really trying to find is the probability that x is between -0.2 and 0.2. And to do that, I would just do the integral from negative 0.2 to 0.2 of f of x. And again, remember that k was 3/8. So if I distribute that, I get 3/8 plus 3/8 x squared dx. And then you just integrate this and you evaluate it. And when you do that, you get 0.152 as the probability that the absolute value of x is less than 0.2, which really means the probability that x is between negative 0.2 and 2. Okay, so here we have an example where Matthias is thinking of fitting an electronic security system inside the offices, and he has been told by the manufacturer that the lifetime in X years of the system he has in mind has this probability density function right here. We're supposed to find the probability that it fails in the first year, okay? So if the lifetime is represented by this and it fails in the first year, that would mean the probability that it fails less than 1, so within the 1 year. That's what we want to find. And so I have the integral. Now, its x is less than 1, so we need to use our lower bound here because that's my starting value. And I'm going to have 0 here and I'm going to have 1 here. So when we say the probability that x is less than 1, we mean from our starting value to 1. And then we have this function here. And you can, of course, distribute this 3x and then simplify this to be able to integrate it. But this is the setup, okay? Again, I'm not going to integrate these because you know how to do this. But when you do this math, you actually get 0.00725. So it's a very small probability that it fails in the first year, okay? Now, I want you to take a minute and set up B. Find the probability that it lasts 10 years, but then fails in the next year. So set that up and evaluate it, and then check your answer with me. Okay, so we're trying to find the probability that it lasts 10 years, but then fails in the next year. So it doesn't make it all the way to the end of that next year. So we want the probability that x is between 10 and 11. And that's just the integral from 10 to 11, as long as those values are between 0 and 20, of this function f of x. And of course, you can simplify that and evaluate it, and you should do it. And the answer you should get is 0.0748. So a slightly higher probability that it lasts 10 years but doesn't make it, or it fails the next year, than it was that it fails in the first year. Okay, so this is a higher probability than this one. Okay, so now using what we've learned and looking at the examples we've done, I want you to take a minute and I want you to do A and B for this problem, and then check your answer with me. Okay, so again, we're missing k here in this probability density function. We want to find k, and that's just saying that my integral from 0 to 4 of kx squared dx must equal 1. Okay, so that's the math that's going to get done here, and then you're going to do kx cubed over 3 from 0 to 4 should equal 1. And then you're just plugging in your bounds and solving for k, and when you do that, you get k is 3 over 64. Okay, for part B, it says find the probability that on a particular day in the high season, there is more than 2 hours of sunshine between noon and 4. And if you read this carefully, it says that this probability density function represents the amount of sunshine between noon and 4. So all we have to worry about is that we want more than 2 hours between noon and 4. So the probability that x is greater than 2, that's more than 2, should be the integral from 2 to our ending point, which here is 4. So from 2 to 4 of kx squared dx, only we know what k is. K is 3 over 64. So this should have been your setup. And when you evaluate this, you get 0.875 as your probability. Okay? Okay, the median m of a continuous random variable is that value for which one of 2 of these are true. So you can use either one. They're both true, but you can use one or the other, and you can look at your probability density function to determine which one you might want to use. But the probability that x is less than or equal to some value m, where m represents our median, would be from negative infinity, we're just using to represent the low value. So from our lowest value that we can have to m, which is going to stay a variable, of f of x must equal 1/2. Because if the area under the curve from my lowest value to m is 1/2, then m has to be the median. We could also say the probability that x is greater than or equal to m, which is the median, is going to be equal to m to my highest value, the integral, from m to my high value needs to equal 1/2. Because again, if from the median to my high value equals 1/2, the area under that curve, then this was the median, was the middle, okay? All right, so let's look at an example. We are to find the median value for the probability density function below. And so what we have to do is we have to know what this means when we see the word median. We are going to say the probability, and I'm just going to use that x is less than or equal to m, is the integral from my starting value 0 to m of 2x dx. And then I'm just going to say that this has to equal 1/2 because it has to, because it's the median that we're trying to find. So now I'm going to add a power and divide by that power. This is my integration. These will cancel. From 0 to m equals 1/2. When I plug in m in here, I get m squared minus 0 squared equals 1/2. So m squared equals 1/2. And m is equal to plus or minus the square root of 1/2. Now, when I do the square root of 1/2, I get 0.707. So normally I would have the positive 0.707 and the negative 0.707. But notice that this only works from 0 to 1. So I'm not going to use the negative value, only going to use the positive value. Okay, the other thing we're going to look at today is expectation and variance. And expectation is our mean, okay? And we have a formula for expectation. And we can use a couple different notations. So e of x here, or this is mu. We can use either one of those. And what we're doing is we're taking our original function, f, our original probability density function, and we're multiplying it by x. So we need to deal with that, and then we need to integrate it. And that's how we find our mean or expectation. To find the variance, which is represented as VARx or sigma squared, we need to take our probability density function and multiply by x squared out front and subtract the mean or the expectation that we found squared. And this part is what everybody forgets. They only do this part, they forget this, and then the answer's wrong. So if you are asked for variance, you actually have to find expectation first. Okay, so let's look at an example. Find the mean, that should say the mean and variance, for the probability density function below. Okay, so for the mean, what we're going to do is we're going to say the integral, and I'm going to have x times this. Now, you can write it like this. I like to go ahead and distribute this first. So if I distribute this, this is going to give me 3/2 x minus 3/4 x squared. So I'm going to write it like that. So x times 3/2 x minus 3/4 x squared. And that's going to be from 0 to 2. So it's going to be for my whole area here, from 0 to 2. And then I'm going to distribute the x. So I'm going to get 3/2 x minus 3/4 x cubed from 0 to 2. And after that, all you have to do is integrate and evaluate, which again, you know how to do. So when you do this, you should get 1 as my mean. So my expectation is 1. So now to find the variance, what we're going to do is we're going to take the integral from 0 to 2 again, but instead of having an x here, we're going to have an x squared of 3/2 x minus 3/4 x squared dx. And then we have to remember to put minus whatever we found here for expectation. So in this case, just 1, but it is squared. Okay, so variance, you have to do this integral with an x squared here and then minus this 1 squared. And you can do all of this math first, and you do all of this, and then you subtract this value. So when you do that math, and actually, let's distribute this. So you're going to distribute this first. So you're going to have 3/2 x cubed minus 3/4 x to the 4th, and then minus 1, because 1 squared is 1. So this part gets integrated, and then you subtract 1. And when you do that, you get 1/5. And that's how you find mean and variance. So you need to know how to find a missing value of k. You need to know how to find the median, the mean, and the variance. So I want you to take a minute and I want you to use this probability density function and find the median, the mean, and the variance, and then check your answer with me. Okay, so over here, I'm going to distribute this first. So this is going to be 4x minus 4x cubed, just so when I plug it in, I can use that. Okay, so for the median, I'm going to have the probability that x is less than or equal to m is going to be the integral from 0, because that's my starting point, to m of 4x minus 4x cubed equals 1/2, okay? And then you're going to integrate this and you're going to plug in your m and plug in your 0 and set it equal to 1/2 and solve, okay? And you should all be able to do that. And when you do that, you get that m is equal to 0.541. Okay, for our mean, we're going to say the expectation or the mean is going to be the integral from 0 to 1, so from my lowest to my highest here, of x times 4x minus 4x cubed dx. And then, of course, I would distribute this x and then integrate and evaluate. And when you do that, you should have gotten 8/15, which is 0.533, okay, as a decimal. So either one is fine. All right, for the variance, we are going to do the integral from 0 to 1, but we're going to have an x squared here of 4x minus 4x cubed dx minus the mean squared. Okay, so you're going to distribute this x squared, you're going to evaluate this integral, and then you're going to subtract 8/15 squared from it. And when you do that, you get 0.0489. And so that's my variance, and that was my mean, and up here we found the median. Okay, so make sure you understand these formulas and how to use them, and we will continue in class.